The following is the details and objectives of this course. Please read it carefully and start the course. The body electrical system controls a variety of convenience functions as a single system. The system controls the washer-linked wipers, anti-theft alarm, lamps, central door locks, and other functions. So, why do we need body electrical systems? As the civilization develops and the economy grows, vehicles are becoming increasingly important in our lives. Vehicles are now a daily necessity for most, and further technological developments have made vehicles even more convenient and comfortable. This progress has led to the development of various body electrical systems. Body electrical systems now control a number of interrelated units quicker and more precisely. Now let's look at how body electrical systems have evolved. The first body electrical system was the time alarm control unit. This system only controlled timer and alarm functions, such as the rear windshield defogger timer and power window timer. The next system was the electronic time alarm control system, which offered more functions than the time alarm control unit. In the electronic time alarm control system, a single computer unit controlled the function of each relay, actuator, and motor. The body control module system eventually followed the electronic time alarm control system. The difference between the two is that the body control module can communicate with diagnostics devices. Vehicle models may differ slightly, but, in general, body control module systems provide the sensor output mode and actuator force drive mode via the diagnostics device. After the body control module, the intelligent integrated platform module began to be applied to vehicles. This provides more functions than the body control module because it connects more units to the CAN communication system, and it also supports error codes for diagnostics. Some vehicles that communicate via the CAN communication system are equipped with body control module. Because the body control module supports an increasing number of functions, many vehicles now include a smart junction box to control some systems. The smart junction box module uses a conventional junction box to implement communication control and diagnostic functions. It also supports error codes. Recent systems use a smart junction box that combines the intelligent integrated platform module and the smart junction box into one unit that can control the entire body electrical system. We will discuss this integrated smart junction box in the next session. The body electrical system is composed of the body control module, a smart junction box, and various switches. The system is controlled in the following way. First, the smart junction box receives signals from various switches and sends these signals to body control module via the CAN communication system. Then, the body control module combines the data received from the smart junction box with its own data, and issues output commands to the smart junction box. Based on these commands, the Smart Junction Box controls the relevant relays and supplies power via IPSs. In other words, the Smart Junction Box receives signals from switches, but doesn't control the system directly. Instead, it forwards the signals to the body control module, and receives commands from the body control module to control the system. The power connector was originally installed inside the Smart Junction Box to cut off parasitic current. However, it had to be inserted or removed manually, and its battery frequently discharged before the vehicle was delivered to the customer. To eliminate this inconvenience, the mode selection switch and auto cutoff relay control system were applied to monitor the condition of the vehicle and automatically cut off the parasitic current. If there is no switch change, or CAN communication sleep mode for 20 minutes, then the auto cutoff relay automatically stops the current. But, if ARM mode is activated after the vehicle is delivered to the customer, the auto cutoff relay automatically stops the current after approximately 60 seconds. The parasitic current auto cutoff device functions in the following way. When the mode selection switch is off, the lamp load, multimedia devices, and various modules receive a constant supply of power via the auto cutoff relay. If the mode selection switch is set to on, the lamps receive power via the auto cutoff relay while multimedia device and other modules are powered by B+ connection. The Smart Junction Box has a fail-safe function for the headlamps. Let's see how it works. In addition to the CAN communication system, the Smart Junction Box uses a backup circuit to detect the headlamp low switch. If the controller is normal when the ignition is on, the Smart Junction Box sends an inhibitor signal through the backup circuit to prohibit its operation. If the controller fails or the CAN communication system has a problem, this system cannot output an inhibitor signal. If this occurs, the backup circuit activates the headlamps and tail lamps when the headlamp low switch signal is input. The operating principles of body electrical systems can be divided into the input and output control mechanisms. First, with pull-up inputs, the unit's constant voltage regulator outputs 5 voltage, and the resistance causes a current of several milliampere to flow. When the switch turns on, the voltage falls to 0 voltage, and this indicates the position of the switch to the module. With pull-down inputs, the module determines the switch position based on the 12 voltage input. With strobe inputs, 5 voltage and 0 voltage currents are alternatively output at initial intervals when the switch is off. Whenever the switch turns on, the current stays at 0 voltage. If the mechanism detects a 0 voltage current for longer than 40 milliseconds, it knows that the switch is on. Otherwise, the mechanism determines that the switch is off. Strobe inputs prevent large amounts of power from being discharged, as vehicles are equipped with more convenience devices and switches. The system is normal if a multi-tester can measure 1 to 2 voltage on the circuit. The body electrical system uses the switch input mechanisms to determine whether a switch is on or off. In vehicles without a communication function, the body control module receives and processes all of the switch signals. In vehicles with a communication function, switch signals are sent to the nearest module, which then relays this information to the other modules via the communication network. Now let's look at the output control mechanism. For output control, the system uses a transistor to control small currents that activate the relay coils and allow large currents to flow through. When the activation conditions for the electrical loads are satisfied, the module turns on the internal transistor to activate the relays. However, as more new functions are added to vehicles, electrical systems are becoming more complicated and diverse. Intelligent power switching devices are used to control these complicated systems. The Intelligent Power Switching Device stands for Intelligent Power Switch, which is a load power control device that uses semiconductor elements. This replaces the conventional ground control that uses transistors, with the power output control that uses Intelligent Power Switching Device. Let's see what new functions can be added with the introduction of Intelligent Power Switching Device. IPSs provide the following functions. Please click each item for more information. Intelligent Power Switching Devices are load control devices that use semiconductors. Intelligent Power Switching Device use a semiconductor rather than a fuse or relay to control the power supply. They also detect open circuits and short circuits by sensing the current and perform self-diagnostics and fault reporting functions. In addition to this, they can switch quicker because they use semiconductors. Finally, they are compact and easy to upgrade. Smart junction boxes use the PWM control method to protect the headlamps from overvoltage. This applies the headlamps with constant power. The normal voltage at the headlamp should be 13.2 voltage. But this constant power control function does not apply to HID headlamps because they have a ballast that maintains a constant voltage. The Smart Junction Box uses ARSU, or Intelligent Power Switching Device, to control the outputs of the exterior lamps and detect possible open or short circuits. If the current flowing through a circuit exceeds 200% of the normal current, the Smart Junction Box identifies it as a short circuit. This applies to all the lamp types. For open circuits, however, the Smart Junction Box only checks the turn signal lamps for rapid blinking, and then outputs the error codes if necessary.